Hey everybody, let's grab the usual thing. Here's a link to the attendance as well as a link to the online tutoring that is available. So if you are looking for some extra help from someone who is not me, who is a student, there is stats tutoring available. If you go on there and click to schedule an appointment, that is an option also. Please do fill out the attendance when you have a chance. All right, so today, sorry, my brain. Today is the Nimdari focus day, although anyone's welcome to ask questions as usual. I feel like there was something else I wanted to say before we get going here. Brain. Oh yeah, there's office hours this afternoon from 1:30 to 2:30. The link for that should be available on Canvas if you want to attend. I could also probably find it and post it here in case you wanted it. Sure, I feel like this always does something weird when I post this, but let's try it. Nope, doesn't want to do it. Okay, it's in Canvas. You can find it in Canvas. It's right in the modules, I believe, in Canvas. Let me take a look really quick just to make sure. Sorry, one sec. My wife is being kind of loud. Oh well, it's life. It's life in this world. Sometimes your spouse is at work and they're kind of loud. Modules. Just want to double check here. No, it's in announcements. That's where it is. Yeah. So the Thursday and the Tuesday Zoom office hour links are in the announcements. If you want to attend the office hours, I guess I can grab it since I'm there now. I might as well, right? So if you feel like you want to ask some questions in office hours later today, there is the link to that. I wish this would actually you can click on the links, but apparently you can't. So you have to copy and paste. All right. So do you guys have any questions specifically or generally? Any topics you want to cover or any specific questions you have? I know, Nimdari, I think you guys have a quiz today. I was trying to look at it. I can't seem to access it, or maybe it's not available yet. Anyway. All right. What do you guys want to do? And I'll be perfectly frank, it's been harder for me to keep up with the Nimdari stuff just because it feels less accessible to me. The Whitener class is very easy just to kind of follow through the textbook with, whereas the Nimdari stuff just feels more challenging to access. So I really do need, if you guys have questions, I need you to, oh yeah, of course. Yeah. Let me send the attendance again. There you go. Yeah, I need you guys to ask questions because I will freely admit I don't exactly know what you guys are up to in Nimdari's class. And you can look at the files and see. Let's see. Let's take a look at what he's doing. Let's look at the handouts. Why not? And handout 7 seems to be the most recent of the handouts. Estimating the target parameter, confidence interval for a population. Oh, confidence intervals. Talking about confidence intervals. All right. That's fun. Okay, this is the one that's not. Let me see if I can find the handout that I think he usually writes on. He's got the handouts and then he's got, where does he put the other things? Discussion maybe. Sorry, I feel like his stuff is maybe not organized the way I would organize it. It's not to say it's wrong, just, you know, people do things differently. Let me take a look here. One sec. I want to sneeze. Sorry, I have like a sneeze coming on and it's really feeling good. One sec here. Yeah, let me do this real quick. Come on. Okay, cool. I see where we're at now. All right. And we can talk about confidence intervals if you guys would like. We can kind of work through his handout 7 if you want, or we could go back further. And then before that, his previous handout seems to be on the central limit theorem, I believe. Or we could do nothing. Guys like, sorry, I know other classes I'd be able to just kind of start going because I know the material better. This is not that class. All right. Let me see. Let me get some light here. All right, so I will just start saying things because you guys seem to be quiet today, which is fine. So let's go ahead and talk about the central limit theorem because it's important. Again, if you guys have questions, feel free to chime in, type something, say something, whatever you want to do. So here's what the central limit theorem essentially says. Basically, if you have some sampling distribution of X bar, right? So you're looking at, gosh, sorry, I have to remember the language. Oh, sure. Can we send a question from the quiz and go through the mood? Yeah, definitely, of course. But yes, sure thing, Destiny. Thanks for providing something. I'm like, let me just start talking. Sure, let's look at quiz questions. And of course, I don't know how to get to the quiz. Okay, so according to the American Automobile Association, the average cost of a gallon of regular fuel at a gas station in May was $3.65. Okay, so let me start writing things down, and I'm going to change up the numbers. So the average cost of fuel, let's say it was, let's make it a little bit more interesting. Let's say it was, I don't know. I mean, so right, that's kind of seems kind of high. Let's say it was 280. Seems more in line with what's going on these days. Assuming that the standard deviation of such cost, okay. So I'm going to say the standard deviation I'm going to say it's 36 cents. And the reason I'm picking that number specifically is because he picked 25 cents, which is a square number. And so I think there's probably a reason he picked 25 cents. Suppose the random sample, he also picked a square number there. I'm going to pick a different square number. Let's say n equal to 225 people. A random sample of 225 gas stations. Apologies. Right, we're not sampling people, we're sampling gas stations. Selected from the population, and the cost per gallon of irregular unleaded fuel is determined for each. So for each of these 225 gas stations, we're going to look at what their cost is. So right, we've got 225 different observations. What is the approximate probability that the sample has a mean fuel cost? So what's the probability that the average fuel cost, which I'm going to call X bar, and I think that's what I want to use right now, is between, so he did something, this seems, I'm going to make ours a little bit different, but it's going to be the same idea. So let's say I want to find what's the probability that the average fuel cost is between, let's say, $2.98 and $2.74. Okay. Let's see. Maybe I didn't screw this up. No, I just want to make sure. Use 25. Sure. I mean, this will be fine. I feel like there might be something weird with the numbers I picked, but whatever. Okay. So, so this is essentially a z-score kind of question. Sorry, let me write my numbers a little more clearly here. Now, here's the thing, right? So this is what we know the population mean is, and this is the population standard deviation. And so this is exactly all about the central limit theorem. The central limit theorem says that if you know the population mean and population standard deviation, and sorry, I need to make sure I read this clearly here. Oh, I have to make sure. Sorry, let's read here. So suppose. So I'm reading his notes about central limit theorem. Let me just say these things. So suppose x1 through xn are independent and identically distributed random variables with mean mu and standard deviation sigmas, right? So we've got x1 through x225, right? Then the probability that you have that is exactly. Sorry. Cool. So here's what I'm trying to say, right? The words are taking a long time to come out of my mouth here. We know that x, right? So x is distributed like this, with this mean the standard deviation. But we're not actually asking about x, or we're not asking what's the probability that one pick has a value between 274 and 298. We're asking what's the probability that the sample you have chosen has an average between these two values. So we're asking what's the probability of x bar, and x bar is distributed slightly differently. If x is distributed with a mean and standard deviation or whatever, then x bar has distribution with a mean of still mu, but the standard deviation is given by mu, the population standard deviation divided by the square root of your sample size. Let me double check on that because I feel like it's right. No, it's right, yeah. Okay. So for this particular x bar, since I might have made bad choices for my numbers, whatever, it'll be fine. Except they might be too big. Yeah, let me change these numbers so our numbers aren't super crazy. Let's do something like, I don't know. Let's probably be between. No, this might be fine. I don't know. We'll find out. I'm not going to split. Let's say between $2.60 and $3, just so it's not feeling quite as dumb. It doesn't really matter what the numbers are. The process is still going to be the same. So here's what we're trying to do. We're trying to find the probability that x bar is between $2.60 and $3. And we know that x bar has a mean of 280 and the standard deviation of 36 cents divided by the square root of 225, which is 36 divided by 50. 36 cents divided by 50, which probably simplifies all right. Let me give you the attendance one more time. For those of you that just joined us, we're doing a problem similar to the quiz problem about the gas stuff. We're finding the probability. So for our numbers here, just in case you missed it, we're saying the average cost of fuel is 280, the standard deviation cost of fuel is 36 cents, and we're asking what's the probability that the average of 225 observations is between $2.60 and $3. And so our standard deviation here, let's see, 0.36 divided by 15. Hopefully that's a nice number. 0.36. It means fine. It's not. Oh, it is. It's 0.024. So 2.5 cents almost. And clearly I picked numbers that are way too big. 0.024. Sorry, let me check that one more time. Yeah, that's right. So my numbers are going to be off the charts here. I should probably change that just so it's not super duper crazy. Yeah, sorry. I hate having to keep changing numbers, but it'll be weird if we don't. So let's say it's something more reasonable, like this is going to feel kind of silly. What's the probability that the average price is between, let's say, 278 and 285? That seems more reasonable since our standard deviation is, right, 0.02. Sorry, my brain is tired. This is $0.024, which is 2.4 cents. Okay. Yeah, that's fine. All right. So we have to change these scores to z-scores, right? And the way we do that is we just do these scores, right? Your z-score is just your score minus your mean over your standard deviation. Which in this case is going to be, so x, so for this one, right, it's going to be $2.78 minus the mean, which is 280, divided by the standard deviation, which is $0.024, right, or 2.4 cents. And calculating this is going to be a negative number. It's negative 0.02 divided by 0.024. Let's get a calculator. So 0.02 divided by 0.024 is 0.833, or sorry, negative 0.833333 forever. And so again, that's just saying we're almost one whole standard deviation below the mean if we're talking a price of 278. And then the other z-score is going to be this one. So 285 minus 280 all over 0.024, which if it's 5 cents above the average, that's going to be a little bit more than 2 standard deviations, right? Because one standard deviation is 2.5 cents. So this should only be, let's see, 0.05 divided by 0.024, which is going to be 2.08333333. Interesting. All right. So our question has been changed into the probability of x being between two numbers to the probability of z being between two numbers. Okay, so that's the first thing you have to do. You have to change your numbers into z-scores. The second thing we have to do is we have to use the table to figure out what area that is. So I'm going to use the table that he supplied you guys with because that seems like the most fair way of doing it. Let me grab his table real quick here. I think it's in the handouts. Yeah, it's a handout to Z table. Okay, so before we actually look at the Z table, let me show you what we're doing, right? So I know I erased the question. So again, we're trying to find the probability that our average value is between, said what, 278 and 285, which is going to be equivalent to the probability that our z-score is between 2.083 forever and negative 0.83 forever, right? Yeah. And so graphically, here's what this looks like. Right, here's our mean, a z-score of 0, or an x bar score of the actual mean, which is $2.80. And we're trying to find the probability of being less than 2.083. And we'll figure out what that's going to be in a second. And negative 0.83. So we're trying to find the probability of being between these two numbers. So we want the area under the curve between those two numbers. And so here's how I'm going to do it using his table. So his table, or the table in your book, right? Not his table specifically, gives you the area to the left of a positive value and then stops at 0. So here's what I would do. I would look up the value for 2.0833, whatever, and we'll figure out where that is exactly. And that would give me this area. And then I would look up the value for positive 0.83333. And that will give me that area. And so this area corresponds to this side here. Right? That's all that. And this area, don't do that. This area corresponds to this side here, which will give me all that. And then I'll add the two together. So that's how I would specifically use his table. So let me share my screen for a sec. So looking at the table, so I'm looking for first 2.0833. So that's going to be 2.08, right? Because I'm going to round to 2.0. And again, hopefully you pick numbers where you don't have to round so much. Looking for 2.08 right here at 0.4812. So this area here is 0.4812. And then this area over here, looking at negative 0.83, or looking at positive 0.83, I see a value of 0.2967. So, right, and that's how I would use this Z table. If you have another Z table you're using, that is also something that's fine, right? I don't know how he feels about using different Z tables, but there you go. So our final answer would be just adding these two together. So that's going to be 0.4812 plus 0.2967, which is going to be 0.7779, which seems reasonable, right? We're pretty close to being between 2 standard deviations above and 1 standard deviation below. And 2 above would be like 47.5%, right? Because it's half of 95%. And 1 below would be 34% because it's half of 68%. And 34 and 40, yeah, that seems close to reasonable. So that's how you would do a problem like this. We can definitely do another one if you would like. I don't mind doing another one that I can just make up with better numbers. Or we can do something different if that was enough for that. And so the answer means for sure. So here's what the question, let's go back to the question. The question was, what's the probability? In fact, let me write it down. Here's what the question was. So here's how the question was written as a probability. And again, so we had, right, we had a average gas price. We knew that the population was, I said it was $2.80. And we had a standard deviation of 36 cents or $0.36. And we had a sample size of 225 gas stations. And so what this is saying is that the probability that the average price of a sample of 225 gas stations, so the probability that the average price of a sample of 225 gas stations is between these two prices is the number we just found, 0.7779, or whatever that was. Yeah, 7779. So we're saying there's a 77.79% probability that the average of our sample of 225 gas stations will be between these two values. Does that clarify things, Kimberly, or do you want me to say more? Cool. And that's what, and so more generally, that's what this typically, so I want to point out that this is different than if we just took, right? So the whole idea, let me speak more generally here. The whole idea with the central limit theorem is that if you've got some population that's distributed some way, basically the idea is that if you look at this, at the distribution of the averages, it becomes a distribution with less variance, less standard deviation. So this is like your typical population distribution, right? So this is how the variable x is distributed. It doesn't actually have to be normally distributed for the central limit theorem to work. Then x bar, the average of some number of samples, which we can pick to be different numbers. The larger n is, basically, the more concentrated this becomes. And sorry, these are supposed to be in the same spot. The mean should end up being in the same spot. So let me draw this more accurately. Basically, you still have a normally distributed thing, but you have a lot more concentration in the middle. Right here, right, one standard deviation is like that far. And you get 68% of the data here. But here, right, you don't have to go nearly as far, right? Maybe your standard deviation is like that much to capture the same amount of data. So when you have how x bar is distributed, it's going to have a much smaller standard deviation because the standard deviation of x bar is the old standard deviation divided by the square root of your sample size. So if you take an average of a lot of things, you're going to get your distribution of x bar to be really, really tight towards the mean, because your standard deviation is going to be a lot smaller because you're dividing by the square root of n. And that kind of makes sense if you think about it, right? If you just said, well, okay, so let me make up some numbers here. And I'm going to go back to one of my standard kind of examples, height of a man, just to make it easy. So let's say, I'm just going to make up numbers, average male height. Let's pretend it's, like, I don't know, 70 inches with a standard deviation of, let's say, I don't know, 3 inches is probably too big, but whatever. So if I just said, okay, I'm going to take one person, I'm going to ask what's the probability that their height, so what's the probability that, someone's height, x, is between, let's pick some interesting numbers. Let's say 72 inches and 68 inches. So that's 2/3 of a standard deviation above and 2/3 of a standard deviation below. Well, I can look at my z-table, right? So looking back at my z-table, actually I should talk about one, right? So this has a z-score of 72 minus 70 divided by 3 is 2/3. Which is 0.66, whatever. So I'm going to look for 0.67. So that's right. And it's the same value here, right? Because this is 2 below. This is negative 0.67. So I look for 0.67 in the z table. 0.67 shows a number of 0.2486. So I know, in fact, since I have a nice symmetry here, I can actually just double that, right? Because what I'm really saying is, right, I'm asking for being between 0.67 negative 0.67. When I look in the z-table, right, it's just giving me this area here. So that area is, again, looking at the z-table, it's 0.67, 0.2486. That's this area. But then this area to the left is the same because of symmetry. So it's actually just double that, or add it again, which is going to be I don't know, 49 something. Sorry. 12, 1, 7, sure, 0.4976. Almost half. All right, but now I want to ask, what's the probability? So let's say I took, I kind of want to stay on the side, whatever, I'll back and forth. So the probability that one person has a height between, one man has a height between 68 inches and 72 inches is almost 50%, 49%. But now let's ask a different question. What's the probability? So let's say I take x equal to 20, sorry, not x, n equal to 25 samples, right? And I want to know what's the probability that the average of those 25 heights is between the two things. So it's the probability that x bar is between 68 and 72. And now here's the deal, right? Taking a sample size of 1 can have a lot of variability, right? You can get someone way out there, but if I take a sample size of 25, there might be a few outliers, but most of them are going to congregate towards the middle, right? That's what the whole central limit theorem is about, is that you have more central tendency the larger and larger your sample is, because more of the people are already grouped in the middle. If you start taking a sample of a bigger and bigger size, you're going to get most of the middle, maybe a few outliers here and there, but the outliers are going to kind of average out. So here, x bar is distributed with the same mean, which is still 70, but now the standard deviation isn't 3, it's 3 divided by the square root of n, which is 3 over 5, which is 0.6. My numbers might be, gosh, I think my numbers are going to be too big for his z table. Gosh, they're too big. Ugh. Fine, let me pick a smaller sample size so the numbers aren't super crazy. All right, so what you'll see here is the power of a sample size 16 doesn't seem that big, but it's going to make a huge difference in how this is distributed. Let's say it's 16 instead of 25, just so the numbers aren't super wacky. The problem is if you get too big, then you're going to be off the z table. So 3 over 4, which is 0.75. So now the probability that x bar is between 68 and 72 is the same as the probability that your z-score is between, well, let's find the z-scores. So the z-score for 72, instead of being 72 minus 70 over 3 like it was on the other side, now it's going to be 72 minus 70 over 3/4, or 0.75, which is 2 divided by 0.75, which is going to be what? 2.666. And in a similar way, 68 minus 70 over 0.75 is going to be negative 2.6666. So here I'm trying to find the probability that z is between 2.67, which I'm going to round to, and negative 2.67. Obviously, that's going to have a lot more area, right? If the z-score is bigger, you're capturing more of the area under the curve. So instead of, looking at these values, I'm going to be way out here. I'm probably going to get like more than 90% of the data. So let's take a look. Sorry. Here's z equal to 0. Here's z equal to 2.67. If I look up 2.67 on my z table, and again, let me share my screen just to make sure everyone's cool with how we're doing this. So looking at the z table provided, if I look at for 2.6 and then go over to the 0.07, 2.67 is 0.4962. So this area here is 0.4962. And since the other z value is the opposite of it, I know that this area over here is also the same. But if it was a different value, I just look at the positive value in my table and then do that. So this is also 0.4962. And if we add 0.4962 plus 0.4962, we get 0.9914 or something. Let's see, 0.4962 times 2. 0.9924, sorry about that. So while if you just take a sample of one person, right, you say, okay, what's the probability that one person's height is between 68 and 72 inches? The probability is, I mean, not low, but it's not particularly high, right? It's 49.72%. But if you say, what's the probability that the average height of 16 men is between 68 inches and 72 inches, then the probability that their average height between those two things is 99.24%, so really high. And that's kind of the whole thrust of the central limit theorem, is that if you take a sample of some number that's not even that large, there's a lot more of it is grouped in the middle. And so your probability of your average being between two particular numbers is a lot higher than the probability of just x being between two different numbers. Thank you, Destiny. Good question. Also, just in case anyone needs it, here is the attendance link again. Also here, here is the link to the tutoring in case you want to make an appointment with one of these student tutors. There is tutoring in stats, I've been told, so you should be able to use that if you want to. They might be more helpful than me in some ways because they probably are more familiar with the material than I am. Yeah. What else would you guys like to talk about? Are there other questions from your quiz that we could modify greatly so that we're not doing anything that would be considered academically dishonest? I definitely do not think this is perfectly fine what we did. No problem whatsoever. I think there was something else. Okay, there it is. Oh, LaTeX, all right. Good thing I know how to read LaTeX. Or LaTeX, I guess it's supposed to actually pronounce. Sure. So let's see what we've got. This feels like a very similar question, but let's take a look. So here's how I'm reading this. We have a random sample of 100 observations. We're selected from a population with a mean. Okay, so let me change the number. So let's say a random sample of how many do I want to pick? Let's go lower. Let's go 64. And again, I'm using a square number because I have a good idea of what's going to happen. 64 observations. We'll call them x1 through x64. We're selected from a population with a mean of mu equal to 50 and variance. So notice he said variance. Variance equal to, let's make it 144. Again, picking square numbers. Is that going to be terrible? Sorry, I should make my life easier. Let's just pick 100. So, because I know I'm going to be dividing things. Sorry, let me think here. 100, maybe. Let's go 256. That seems nice and not terrible. And you'll see why in a minute here. Okay. So determine the probability that x bar, meaning the average, so probably that x bar is between two numbers. So let's see, a little bit above and a little bit below the mean. Sure. So let's say, let me think before I make up numbers here. It's a large-ish variance. I might pick that to be too big. That's fine. Let's see. Sure. Let's go, I think this will be fine. Let's go 53. Let's go 40. Sure, 45. It's probably going to be most of it, but whatever. Okay. Seems good. This is definitely the same sort of question that the previous one was. So we're going to have a probability that the average of 64 observations is going to be between 45 and 53, which you might think seems like a pretty tight range, considering that we have a variance of 256, which means we have a population standard deviation of the square root of 256. which is 16. And if your standard deviation was 16, it seems like it'd be hard to have, or not very likely, right? It seems like it would be a pretty low probability, at least that X would be between 45 and 53, right? Because, 50 plus 16 is 66, and my 16 is 34. 34 to 66 would be 68% of the data. This is going to be much less than that if it was talking about X, but we're not. We're talking about X bar. So again, we have to remember that X bar is distributed with mean still mu, which is 50, but standard deviation, sigma over the square root of n, which is, so not 256, right? It's 16 over square root of n, which is square root of 64, which is 16 over 8, which is 2. So just to make sure everybody knows what's going on, right? For X bar, the mean is mu. The variance is sigma squared over n, and the standard deviation is sigma over the square root of n. So I could do this, right? My variance is my 256 over 64, which is just 4, and then the square root of that is, this is the square root of the variance. Square root of 4 is just 2. So once you translate everything into this kind of situation, now we just have to say, okay, what are my z-scores? So I'm trying to find the probability. And so I want you guys, I'm going to ask you a question, make sure you have a z table to look at. So the probability that X bar is between, sorry, I said 53 and 45, I think. Well, we know that their mean is 50. We know that their standard deviation for X bar is 2. So I'm really trying to find the probability that, in fact, let me just do it this way. Right? X bar minus the mean divided by the standard deviation. I'm just doing the same thing each of these. That is between this number minus the mean divided by the standard deviation, and this number minus the mean divided by the standard deviation. I'm just doing the same thing to all of them. But now this is what gets to be called the new z-score. So I'm going to try and find the probability that z is between 53 minus 50 is 3 over 2 is 1.5, and 45 minus 50 is 5 over 2. Sorry, it's negative 5 over 2 is negative 2.5. Okay, so if I was going to do this, well, again, right, I'm trying to find, I'm actually going to ask a follow-up question for this. So I want you guys to go ahead and find the values in the table. Right, if I'm over here at 1.5, and over here at negative 2.5. Right, I'm trying to find all the area between these two values. So would anyone like to volunteer? What's the area in blue? How much is that if I look at my z table? All right, I know what it is. Does anyone want to tell me what it is? Yeah, excellent. All right, how about the area under the red part? Oh, sorry. I can, oh no, I'm looking at the wrong number. Yeah, 0.4938, excellent. So I think it's 4938, Kimberly. I think you might have interchanged the 8 and the 9 there. Or the something and the something. I do think it's like, I'm looking at 2.5 on my table, right? It is 2.5, right? Yeah, and I'm seeing 0.4938 instead of 893. So hopefully, I don't see it. I think you looked at 2.3 accidentally. Yeah. And they happen to have the same digits. right? 0.4938. And so then to get the right answer, we would add these together, right? So I want this area plus this area, and that would be some number that doesn't really matter, but we'll find it anyway. 0.4938 plus plus 0.4332 is 0.927. Or 92.7%. So again, what that means is if you have a sample of 16 whatevers, right? Because we didn't say what these were. We have a sample, 64. We have a sample of 64 observations. The probability that the average of those observations is between 45 and 53 is 92.7%, or 0.927. Now, I do want to ask an extra question here because I think it's worthwhile. What if instead, so I'm going to change, sure, I'm going to change it. Yeah. So what if instead I asked for the probability that X was between 51, or sorry, X bar was between 51 and 53. So that's going to change things a little bit. Sure. So this is 51. 51 minus 50 is 1 divided by 2 is 0.5. So now I can look both these up on the Z table, right? So this one still gives me this area here, but looking at 0.5 is going to give me what? 0.1915. So for 0.5, I'm getting, right? So here's 0.5, and I'm getting that area there is 0.1915. And here's the thing I want to say. In this case, we don't add the areas together, right? Because we want the area between 1.5 and 0.5. So we're actually looking for, right? We're looking for this area here, which is all of this area here minus this area in green here. So that's going to be 0.4332 minus 0.1915. So I'm just trying to point out that you have to be careful how you read the table, or how you are, to make sure you're correct using the table. So in this case, the answer would be 0.4332 minus 0.1915, which would be 0.2417. So basically, what I would say pretty generally is, for the Z table we're using that he has provided to us, if both of your Z values are the same sign, and if they're both positive, you're going to be subtracting the areas to find out how much is between them. Or if they're both negative, you just look at the positive values and subtract the areas to get how much area is between them. If they're opposite signs, then you're going to add the values together, right? If one's positive and one's negative, you're going to look at the positive value, get that area. You're going to look at the corresponding positive value to the negative one, get that area, and then add them together. So that's how this Z table happens to work. Right, I think that's about all the time we have for today. Again, I do have an office hour this afternoon from 1:30 to 2:30. So if you have further questions, I'm happy to talk to you in a less group setting later on. If you do come to office hours, I would please request that you do turn on your video, just because it's nice. It's weird to talk to just one person without video. So, but if you really don't want to, I totally understand. All right, take care. Good luck on your quiz. And we'll see you all next week. And also, speaking of quizzes, I will get your guys' quizzes that I gave you graded today so that you can have that feedback as well. I meant to do it yesterday, but I got kind of busy doing other things. So we'll get that done today. You're welcome. See you guys later. You too.